Hello there guys, welcome back to another epic inexorable maths video. So in this video we've already looked at arithmetic sequences before. So arithmetic sequences are just sequences that have a first term and then each term after that has a common difference between it. So that might be the number 4, it might be the number 5, it might be the number -1, whatever. So to go from one term to the next, you are either adding or subtracting a number that is always the same for every single term. That is what an arithmetic sequence is. So a series is the exact same thing, but you're adding all of the terms together. So if you wanted to find the sum of the first n terms of an arithmetic series, then you would use this formula here, which we're about to derive. And I've just labelled A is the first term, D is the common difference, and N is the number of terms. Some people use U1 as the first term. They use the symbol U1. So if you use that, and it's the same formula, but just there's a U1 right there. Don't be confused. A is the first term, but U1 can be the first term as well. Just replace this with a U1 if that's you. Okay, if you want to do that. Oh, that was awful. So guys, I'm going to derive this formula for you right now, and let's just see what happens. So I'm going to do it down here because I have more space down here because I'm going to do quite a long line. So that's why I'm starting in the middle of the board. So I'm going to write down what the sum of the first n terms of some general arithmetic series is, okay? So it's just like a sequence, but I'm just going to add every single term together. So the first term of any arithmetic sequence or series is just A, because A is the first term. Again, this would be U1 if you prefer that notation. Okay, if it was a sequence, what would the next term be? It would be A plus D. But we're adding that, so we're going to add A plus D. That's the second term. The third term would be A plus 2D. Okay? Amazing. And we're just going to keep going all the way until we get near the end. And at the end, I'm going to write the last, let's say, 3 terms of this. So we're going to have A plus, or I'll do the last 3 terms. We'll have A plus n minus 3d plus A plus n minus 2d. And the last term, of course, we're going up to n terms, is just the nth term of the sequence, which is A plus n minus 1d. Because the nth term of an arithmetic sequence is A plus n minus 1d. So this will be the last term, if we're counting n terms. Now that's great. It looks pretty complicated, right? Obviously, this is no match for how concise this formula is. We want to show that this Sn, the sum of the first n terms, is equal to this. That's what we want to show. Okay, well, how are we going to do that? Well, this is basically how you do it, okay? So it's not exactly something you might expect, but if you've seen it before, then you've seen it before, and if you haven't, then you haven't. We're going to rewrite the exact same thing again, guys. I'm just going to write the whole thing again. But this time, I'm going to write the terms in the reverse order. So I'm going to write the last term first and the first term last. And you're going to see something very cool. So the last term is A plus n minus 1d, of course. That's the last term. The second to last term is A plus n minus 2d. The third to last term is A plus n minus 3d. Okay, and then we're going to go all the way, I should have a plus there, all the way until the first 3 terms, going backwards, we're going to have A plus 2d plus A plus 1d plus the first term, which is A. So hopefully you can see, I'm just going to move out of the way, hopefully you can see these are the exact same. I've literally just written them in reverse order, but they're the same. Okay, so that's why they're both equal to Sn. Now what we're going to do, this is really clever, we're going to add them together in a kind of vertical way. So I'm going to add the terms like this all the way to the end, and you're going to see something awesome that happens. So the sum of Sn and Sn again, we're going to add the first term and the first term, the second term and the second, the third and the third, all the way to the end. So we need to do A plus n minus 1d. So I'm actually going to do it just up here, just so you can see exactly what happens, and you can see I'm not cheating you. So I want to show you what A plus a plus n minus 1d is. Okay, what is that? Well, a plus a is 2a. So we have 2a plus n minus 1d. So that's the sum of the first and the first term. So we have 2a plus n minus 1d. Cool. All right, what about the second terms? So we have a plus d and a plus n minus 2d. Okay, so a plus d plus a plus n minus 2d. Well, okay, well, what will that be equal to? Let's have a look. So we have a plus d plus a, so I'll say 2a plus d, and then plus n minus 2 lots of d. Okay. If we expanded this out, we would have n times d minus 2 times d. But we already have a d there, so we have a d minus 2d. So this is 2a plus d minus 2d, so just minus d, plus nd. So plus nd minus d. And then we can factor the d out. So we have 2a plus n minus 1 d. Oh, hold on. It's the same. It's 2a plus n minus 1d again. That's crazy. So the sum of these two terms is also 2a plus n minus 1d. And, you know, for the sake of time, I'm not going to do the third one, but hopefully you can see what's happening is the number of d's in the top line is going up by 1 every time, and in the bottom line is going down by 1 every time. So the total number of d's is always n minus 1d, and the number of a's is always 2, because you're adding an a with 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 an a, always. So for every single term, for all of them, all the way until the end, even if, you know, if you look here, it's symmetrical, right? You're once again doing a plus n minus 1d plus a. But we already did that at the beginning, so you can see it really is symmetrical. So you're going to have all the way to the end, all the way, and you know, the last term as well is going to be 2a plus n minus 1d. How many of these are there? Well, we did it n times because there are n terms. So 2 times Sn is n, write that again, n times 2a plus n minus 1d. So n times 2a plus n minus 1d. That's 2 lots of Sn. So if we divide both sides by 2, we will have that Sn is n over 2 times 2a plus n minus 1d. And that is all there is to it. So that's where you get this formula from. That's the derivation, okay? That's the derivation. Hopefully I made that nice and clear. Now we're going to do an example. So the question is, find the sum of the first 50 terms of the arithmetic series 32 plus 27 plus 22 plus 17 plus 12 plus ... And there's 50 terms, okay? First of all, we know that it's an arithmetic series already, they tell us, but if you wanted to check, you could look at the common difference between each term. Is the difference between each term a constant? Yes, it is. 32 to 27, you're taking away 5. 27 to 22, you're taking away 5, taking away 5, taking away 5. So it is an arithmetic series. So what we do now, guys, is we need to identify what A is, D, and N, and we just plug into the formula. It really is that simple. So the sum of the first 50 terms would be n over 2. N is 50. So 50 over 2 times 2 lots of the first term. The first term is 32. So 2 times 32 plus n minus 1 lots of the common difference. So n minus 1 is 49. And the common difference is -5 because we're taking 5 away. Careful of that negative sign. So we're taking away 5, so the common difference is -5. Okay. And then, if you have a calculator, then this is pretty much pebbles, it's pretty easy. 50 divided by 2 is 25. 2 times 32 is 64. 49 times minus 5 is minus 245. And 25 times, this is minus 181. And 25 times 181, negative 181, is minus 4,525. Sorry guys, I couldn't do that one in my head. Yep, it's minus 4,525. Okay, minus 4,525 is the value of the first 50 terms. You might say, why is it negative? Well, most of the terms are negative because it's counting down. So before long it gets to 0 and then you're adding up a bunch of negative numbers. So it makes perfect sense for it to be negative. So guys, we're going to do more questions in the next video and I'll see you there. Thank you guys so much for watching. I highly appreciate it and I'll see you in the next one. Cheers.